Exponential and logarithmic equations. We can use all of the exponent and logarithm rules to solve equations that have variable exponents. These first problems say expressing each side as a power of the same base. So the first problem says 3 to the power of x equals 81. So there's a rule that says if you have a number to an exponent and then you have that same number to another exponent and they're equal, if the bases are equal, then the exponents have to be equal. So we're trying to get the bases to be equal. 81 can be written as 3 to the 4th power. So I can write 3 to the x equals 3 to the 4th. And then, since the bases are the same, I can set the exponents equal, so x equals 4. The next one is 5 to the power of 3x minus 1 equals 125. Again, we can make the bases the same because 125 is 5 to the 3rd power. So 5 to the 3x minus 1 equals 5 to the 3rd power. And then I can set the exponents equal. And then just solve that little equation. So add 1, 3x equals 4, and divide by 3, x equals 4/3. For this problem, you can't really make 8 be a power that ends up being 32, or you can't make 32 into something to a power that makes 8, but both of them can be made into 2 to some power. So 32 is 2 to the 5th power, and that little x is already there, so it's 2 to the 5x. And then 8 is 2 cubed. Now that the bases are the same, we can set the exponents the same. 5x equals 3, and divide. Now, of course, this won't always work. Suppose we were 3 to the power of x equals 10. There's no way you can change 10 into 3 to some power. So there's got to be another way to do it. We'll use logarithm properties to solve problems like this. We want to solve 10 to the power of x equals 14.3. We're going to have to use our calculator and we'll round to 4 decimal places. So remember the rule that says if you have the log of a number to a power, then the power can move out front. So if I put log in front of 10 to the x, then the x can move out to the front. But if I put log on one side, I have to also put log on the other. So I have log of 10 to the x equals log of 14.3. Now that 10 to the x has log in front of it, the x can move out front. X log 10 equals log 14.3. Now the x is not floating in the sky anymore. I can get it by itself. I need to divide both sides by log 10. And then you can just put that in your calculator. Log of 14.3 divided by log 10. And we need to round that to 4 places, so that would be 1.1553. The next one is 10 to the power of x minus 2 equals 348. Again, to get the x minus 2 down from the sky, we need to do log on both sides. And then the x minus 2 can move out front. I put it in parentheses if there's more than one term. It's technically not correct if you don't. X minus 2 times log 10 equals log of 348. Now we're trying to get the x by itself. Let's divide both sides by log 10. And we have x minus 2 equals log of 348 divided by log 10, and then finally add 2 to both sides. Now put all of this in the calculator. A lot of times when you, especially on the graphing calculator, when you push the log button, it gives you a parenthesis. So you want to make sure you close it. and then rounded to 4 places is 4.5416. This equation has the number e in it, and to cancel out the e, you have to do the inverse of e, which is natural log. So to get rid of an e, you natural log both sides. So I have natural log of e to the negative x equals natural log of 0.0142. The natural log and the e cancel. The x just drops down. Negative x equals natural log 0.0142. And then divide out the negative. And just put a negative in front on the other side. That goes in the calculator. X is 4.2545. You can check all these answers, but just keep in mind it won't be exact because we've rounded, but it should be really close. Here we have an e again. We want to get the e all by itself before we natural log both sides. So let's divide both sides by 9. E to the x plus 2 equals. Now 107 over 9 doesn't come out to anything nice, so let's just leave it. We want to minimize rounding. Then we'll natural log both sides. X plus 2 equals the natural log of 107 over 9, and then subtract 2. So all into the calculator. We end up with x equals 0.4756. Remember the formula to go back and forth between log form and exponential form that's written right up here. We're going to use that to solve equations that have log in them from the beginning. I don't know what that green squiggle is about, so don't worry about that. So 5 is the base. Our little base grows up, becomes a big base, and then the 3 and the x switch sides, so it becomes 5 to the 3rd power equals x. And then you just cube the 5, 125 equals x, and that one is solved. I'm going to put a different one here. I want to do log base 5 of x minus 7 equals 2. Okay, we're going to rearrange that one as well. Little 5 grows up. The 2 and the x minus 7 change sides, like that. 5 squared is 25. And then add 7. And x is 32. That one. For this next problem, we need to use the property that e to the power of the natural log of x just equals x. The e and the natural log cancel out. So this problem has a natural log in it. Let's get the natural log by itself before we start. Subtract 6. 2 natural log x equals negative 1. Divide by 2. So the natural log of x equals negative 1/2. Now, to get the x by itself, we have to make natural log a power of e. So we're going to do e on both sides, e to the power of, and we have x equals e to the power of negative 1/2. And you can put that in the calculator, round to 4 places, and x is 0.6065.